So what we are seeing here is, this is I should say the formula or an equation for finding your new position x dash y dash when a pivot point xr yr is given, and you have to rotate your xy, I should say keeping this xr yr as origin. Okay, so this was your equation. Now we shall see something about scaling. So in scaling, what happens? Here we actually change the size. Okay, actually we change the size of the object. Okay, suppose this was your object. So what can happen? The size can increase or the size can decrease. So this may happen in scaling. Okay. Now how this scaling can be done? Okay. Here you can understand that what actually you are doing. This position is this object is a scale, which means all these pixels are actually multiplied by some scaling factor. Okay, this scaling factor is multiplied by each of the pixels to get the new pixel. Okay, so a scaling factor, let me say if you want to have your new x dash y dash, okay, then what happens? This pixel is to be multiplied by something. Your original pixel was x, y, so it will be multiplied by something to get the new position x dash y dash. Okay, so what is this? X will be multiplied by a scaling factor for x, and y will be multiplied by a scaling factor of y. Simple. This can also be represented in matrix form, where your new x dash y dash will be equal to your multiplication of something with your x and y. Okay, what are you multiplying here? You are multiplying sx to x and sy to y. Okay, so you can write it something like this. Your new p dash is s dot p. Okay, very simple to understand. Here you can see that this S is what? Is a 2 by 2 matrix, where the first value Sx represents the scaling factor for x and Sy represents the scaling factor for y. Okay, now you tell me one thing. I have an object here. I want to scale it. This was a position x, y, and this was another position x2, y2. I want to scale it. I want to scale it like I want to make it bigger. Okay, twice as big it is. Okay, let me repeat what I want. I want to make it twice big as it is. So what should be the scaling factor? What should be the scaling factor?
So 2.
Yeah, 2 and 2. It will be multiplied with your x and y with all the coordinate values. Suppose, do you really need all the coordinate values? Maybe you may need only the vertices of this thing, and once the vertices are positioned, you can make the line again, join the line again. Okay, now suppose this position was already something. Okay, let me say it was 5 comma 5 and this was 10 comma 10. Okay, now I am multiplying, so it will be 20 comma 20. Do you agree? This position xy is being multiplied by this 2 and 2. So the new position for this vertex will be 20 comma 20. Do you agree?
Yes, sir.
So this 10 comma 10 is multiplied by 2 by 2. So the new position is somewhere 20 comma 20. Okay. For this 5 comma 5, it will also be multiplied by 2 2. What will be the new position?
10 comma 10.
10 comma 10. Okay, this is the new position for your x2 dash and y2 dash. Okay, this is x dash y dash. Okay, this is the position. Suppose this was something like 5 distance na? So let me take it as 10 comma 5. What will be the new position? 10 comma 5. It is 20 comma 10. Is it?
Yes, sir.
This position is something like 5 comma 10. So the new position will be 10 comma 20. Is it? Correct. And once you have got this vertex, you can connect them to make the join them to make the bigger this thing. Do you have any problem here?
Yes, sir. The position is changing.
Position is changing. What is this? This should have not happened. Something is happening here. What has happened actually? Means if your object was here, it should have grown, right? Grown means either it should have become like this, okay, or something different as per our need, right? But this has something happened which I don't think we wanted, right? What do you think? Where are we wrong? This was our initial object. We wanted to make it twice bigger. We knew the formula. We multiplied by 2 all the points x and y, and we got this result. However, we expected another result like this. Why did it happen?
So because the center is not origin.
Okay, because it was not aware of the center. Okay, that means you want to say that this object, if you want to make it bigger, first of all you have to decide what should be the pivot point. Mostly I believe you can take the origin or the midpoint, whatever you call it, center, I should say, the center as the origin, right? So while scaling this object, you will consider this origin, this center place also, so that after scaling, definitely after scaling, the center remains same. Okay, but in our case center has not remained same, center has also changed. Now what to do? So one option is to bring this object to the origin, scale it, okay, and then again translate it back. So this position will come here, this position will come here, and another positions will come here, and the center will remain as it was. What do you say? Is it a good option? Are you saying something?
Sir, it may be a good option, but I think the time complexity will be more.
Okay, the time complexity is more. He is saying there are three things that you are doing, sir. What you are doing, first of all, you are translating it to here. Again you are performing the scaling, and you are again translating it back to there. Is there some other way? Is there some way that I could multiply it directly to the pixel and get this position? It may be. Maybe you will see such things now after this, when we will see the homogeneous coordinate system, means matrix representation kind of things, where we will adjust multiple transformations in one matrix and multiply them to get our desired output. But one thing is very clear, that there is no other option than this. You will have to translate it here, scale it, and move it back. However, what we will see is we will perform all the three operations in one multiplication itself, so that we will get the desired result. One more thing that I would say here about this scaling is, here we have scaled according to the center point. Sometimes the scaling may also be from any other desired points, maybe any endpoint. You may consider this endpoint and scale it. In that case, what will happen? This endpoint will remain here, however, the object may grow like this. Okay. Similarly, you can choose any other endpoints as well. Not only this, you can also decide any of the point and allow the object to grow. In that case, since the object is here, this point is here, what will happen? In this portion it will grow a little, and in the other portion it will grow more. That is the thing. The formula will remain same. You are just translating, scaling, and translating it back. That's it. Till now, any question if you have? So if the value of scaling factor Sx or Sy, if it is less than 1, then the object will I should say the size of the object is reduced. Object size reduces. Okay. If this scaling factor is more than 1, what will happen? The object size increases. Now if it remains 1, then what will happen? If
Same size.
if x and y remains 1, then it is of same size, doesn't change. Now there are two more things. One is, okay, let me write it in a new one. See, if Sx is equal to Sy, let me write double equal to so that you people can understand that we are comparing. If Sx is equal to Sy, what do we call such kind of a scaling? If Sx is not equal to Sy, in that case, what do we call it? If Sx and Sy are same, what is the effect? The effect is the object will grow proportionally in both the direction, in x as well as in y, right? So such kind of scaling will be called as uniform scaling. However, if they are not same, suppose Sx is 1 only and Sy is 2. In that case, the object will grow in y direction, however, it will remain same in x direction. Okay. So such kind of scaling can be called as differential scaling. Okay. So these are the few things that I would like to say in scaling. Now I believe we can start something related to matrix representations. Okay.